In this video, we are going to look at distance and how to find the distance between 2 points. And this will help when measuring perimeters. So on a number line, it's easy to find the distance between 2 points. Let's say you're starting at unit 1, so you have a point on 1, and a point on 5. The distance between those is simply the number of steps, or the number of units between them. So 1, 2, 3, 4. So the distance between 1 and 5 is 4 units. Finding that, the distance d is just equal to the absolute value of one point, so let's call that point A, minus another point, call that point B. So if we were to start at 5 and find the distance to 1, it would just be absolute value of 5 minus 1, which we know to be the absolute value of 4, which is a positive 4. If we were to start at 1 and go to 5, it would be 1 minus 5, which we know to be the absolute value of negative 4, which would still be that positive 4 units. But let's say you have to find the distance on a coordinate plane. Here I've drawn a simple coordinate plane going from negative 4 to positive 4 in the y direction and negative 5 to positive 5 in the x direction. So this is my x and this is my y. Now let's say we have to find the distance between this point and this point. So let's say this is point F and point E, and we need to find the distance between those two. Well, unlike a number line, we can't just count across until we find it, because those units are going diagonally. However, there is a simple formula that we're going to discover to find the distance between F and E, regardless of whether they're on a diagonal, vertical, or horizontal. So, if you remember the Pythagorean Theorem, it states that a squared plus b squared equals c squared, where a and b are the sides of the triangle and c is the hypotenuse. So let's go ahead and create sides a and b using f to e as our hypotenuse c. So this is our hypotenuse C. Now we just create the triangle. So we need to go down until we reach F in the vertical, and we need to go across until we reach F and E in the horizontal. So our horizontal distance we're going to label as A, and our vertical distance we'll go ahead and label as B. But these are essentially interchangeable, the labels. So, from this point F to this point where A and B intersect is the distance in the x direction to go from F to E. So if we move F over, we're going to be lined up with E in the x direction. So this is our change in x. So we're going over 1, 2, 3, 4, 5 steps, or 5 units. And to find B, that's our vertical distance to go from F to point E. And we're going up 1, 2 units. So B is 2. We have 5 units and 2 units. We have our A, B. Now we can solve for our last variable C. So all we need to do is plug it in. So it's going to be 5 squared which is a squared, plus 2 squared, which is b squared, equals our c squared. 5 squared is 25, plus 2 squared is 4, equals c squared. 25 plus 4 is 29, and we need to take the square root of that 29 because we need to take the square root of c squared. So the distance f to e is the square root of 29, which on a calculator would give us about 5.39 units. So let's go ahead and round that to 5.4. So the distance from F to E is approximately 5.4 units. So the distance D of our line C, which goes from points F to point E, is 5.4 units. So let's go ahead and look at the distance formula. So we're going to say our distance D is equal to the square root of our a squared plus b squared. So you can see that c is equal to the square root of a squared plus b squared, so our distance d is equal to the square root of this distance a, which a was the change in x. So x2 minus x1 squared. Point F is at coordinate -3, 0. Point E is at coordinate 2, 2. And you can see that when we subtract 2 from -3 or -3 from 2, we get a -5 or a +5. But it doesn't matter because whether it's a positive or a negative, it's getting squared. So the answer is going to be positive. So you can see that that distance was 5. So the change in the x coordinate squared. So that would be 5 squared. Plus, now that we took care of the horizontal direction, so the difference in the horizontal direction between F and E, we have to take care of the vertical direction. So that's simply the change in y. And that would be y2 minus y1, and that quantity squared. We went up to, or we went down to, -2 or +2, when you square it, it's going to be a +4, which we got when we did the Pythagorean Theorem. Also, you can see that the y-coordinate, so this can be y2, is 2, and we subtract the y-coordinate from F, y1, and we get 2 minus 0. 2 minus 0 is just 2, and 2 squared is 4. So this is the distance formula. D equals the square root of the change in x squared, so x2 minus x1 squared, plus the change in y squared, y2 minus y1 squared. Using this, we can find the perimeter of a figure on a coordinate plane. Here I have drawn a quadrilateral in a coordinate system. We're going to name this point E, this point F, G, and then H. So E falls at 0, 3. F falls at 3, 3. G falls at 3, 0. And H falls at -3, 0. So using the distance formula, we're going to go ahead and find the perimeter of this quadrilateral, so the perimeter P. However, writing our distance formula, D is equal to the square root of x2 minus x1 So the change in x plus, so the change in x squared plus the change in y squared. Let's start with our easier sides. So from E to F, we can use this just like a number line because it's a straight line. So there is no vertical change, so the 3's and the y stay the same, so the change in y is still 0. However, we have a change in x. It goes from 3 to 0. So x2, 3 minus x1, 0, plus, we know our y already is 0. So that's the square root of 3 squared plus 0 squared. And the square root of 3 squared plus 0 squared is just the square root of 3 squared. And we know that to be 3. So this distance from E to F is 3. You could also just count if you wanted to, since it's on the same horizontal line. 1, 2, 3 units over. Looking from F to G, we don't have a horizontal change, but we have a vertical change. So x2, 3 minus 3 squared, 3 minus 3 squared, plus y2, 3 minus y1, 3 minus 0 squared. So this, again, is going to be 0 squared plus 3 squared. And we know that to be just the square root of 3 squared. And we know that is equal to 3. So the vertical distance, F to G, is 3. And again, since this fell within the same vertical line, we could have just counted units. 1, 2, 3. Now we have to find the distance from H to G. And let's go ahead and just count on this one, since they fall on the same horizontal line. 1, 2, 3, 4, 5, 6. The distance from G to H is 6 units. Now, let's go from H to E. H to E has both a vertical change and a horizontal change, so we definitely need to use the distance formula. Let's use E as our x2 and y2 coordinates, and H as our x1 and y1 coordinates. So we're going to have 0 minus a negative 3, which would be the same as plus a positive 3, squared, plus 3 minus 0, squared. That is going to give us 3 squared plus 3 squared. And we know that 3 squared plus 3 squared is going to be 9 plus 9. 9 plus 9 equals 18. So the distance from H to E is the square root of 18. So approximately 4.2 units. So now for the perimeter, we just have to add all of the sides up. So 1, 2, 3, 4 sides. So P equals 3 plus 6 plus 4.2. And that's going to be equal to 16.2 units. So our perimeter is 16.2 units. So that is how you use the distance formula to find the length of the sides on a polygon, which in turn will help you calculate the perimeter.